Freeze or a refrigerator. This freeze or refrigerator is nowadays so much essential that at every household or family refrigerator is available. We are becoming so much dependent on a fridge for our different purposes. A kitchen without a refrigerator is not possible nowadays. We all know what is the function of a refrigerator, but many of us do not know how this refrigerator functions. So today we will learn how the fridge is functioning, what are the major parts of a fridge, because today the topic of my class is vapor compression refrigeration cycle. Hello everyone, I am Dr. Deepak and do welcome you all to my channel. Today in this class we will learn the vapor compression refrigeration cycle, and then we will learn the reverse Carnot cycle, and finally we will compare this vapor compression refrigeration cycle and the reverse Carnot cycle, so that we can understand how the reverse Carnot cycle has been modified to get the vapor compression refrigeration cycle, and what are the modifications made in the vapor compression refrigeration cycle to make it practical cycle. The very interesting fact about the refrigerator is that we have different gadgets, different machines in our house for different applications, but the refrigerator is the only machine which remains on for 24 hours. A fridge will remain on, it will be working for 24 hours. So the refrigerator we are talking about is functioning on the basis of vapor compression refrigeration cycle. Okay, so before learning this cycle we must know the machine components which are the part of this refrigerator. The major components of a fridge are the compressor, condenser, expansion device and evaporator. So the first one is compressor, second one is condenser, third one is expansion device, fourth one is evaporator. Okay, so these are the four major parts of any fridge. Okay, so based on these different organs our refrigerator will work. So to understand how these machine parts are attached, so we must draw the schematic diagram. So this is compressor, this is condenser, expansion device, so this one is compressor, that one is condenser, this is expansion device, this one is evaporator. So I have shown all these major parts, okay, which are connected through the pipeline for a particular vapor compression refrigeration cycle. Okay, so what's happening here? So these four major components of any freeze are connected in such a way that the working substance, which is called a refrigerant. So refrigerant is continuously flowing throughout the pipeline of the freeze. That means through all the major components of the freeze, the refrigerant will be flowing. So when in the compressor, the refrigerant will be in the compressor, the refrigerant will be compressed. After compression, this refrigerant with higher pressure will come to the condenser, and inside the condenser, the very interesting fact is that for making a cycle, okay, the refrigerant, which is the working substance, it will be changing its phase. Okay, so at some part of the machine component, the refrigerant will be in liquid condition. At some point of the refrigeration cycle, the refrigerant will have a vapor phase. So refrigerant is changing its phase throughout the cycle. Okay, so a refrigerant inside the compressor will be compressed. Okay, so after compression, the pressure of refrigerant will be increased. So this gaseous refrigerant will come to the condenser. Here condensation process will take place. So the gaseous refrigerant will be converted into the liquid refrigerant. After condenser, the liquid refrigerant will come to the expansion device. So here the opposite process of compressor will take place, where the pressure of refrigerant will decrease. So here the liquid refrigerant will have a low pressure, and then it will come to evaporator. So inside the evaporator, the liquid refrigerant will be evaporated. That means the liquid refrigerant will be converted into the gas or vapor. Okay, so after becoming vapor, this vapor will come out from the evaporator. It will come to compressor again. Here the compressor, inside the compressor again, this gaseous refrigerant will be compressed. That means then it will come to the condenser. So in this way, the whole process of the refrigeration cycle will take place. Okay, so in the compressor, the process which is taking place is reversible adiabatic compression. In the condenser, the process which is taking place is the condensation process at constant pressure, and in the expansion device it is isenthalpic expansion. In the evaporator, evaporation process will take place, where the phase change from liquid refrigerant to vapor refrigerant will take place. Okay, so this is the evaporation process at the constant pressure. Okay, so let me write the processes which are being taken place in all these major components. So in the compressor, reversible adiabatic process will take place, and in the condenser, condensation will take place. Condensation will take place inside the expansion device. The isenthalpic process will take place inside the expansion device, and in the evaporator, evaporation will take place. Okay, so in this figure, what we understood is that in the compressor, the pressure of refrigerant will change. Okay, the pressure of refrigerant will increase. Inside the condenser, condensation process will take place, where heat rejection will take place. So whatever heat it is there with the refrigerant, that heat will be rejected inside the condenser. Okay, and from the condenser, the refrigerant will come to the expansion device, where again its pressure will drop. Okay, so its pressure will decrease. So after having the low pressure, the liquid refrigerant will come to the evaporator. So these are the constant pressure. So this is the Carnot cycle. So 1, 2, 3, 4. Okay, so this cycle is reverse Carnot cycle. Okay, so process 1, 2, 2, 3, 3, 4 and 4, 1. This is a reversible, adiabatic compression process. It is the condensation, at a constant pressure, and that one is reversible adiabatic expansion. This is a reversible adiabatic expansion. This is evaporation process. So here, this is reversible adiabatic process. Adiabatic. This is condensation, same as the refrigeration cycle. This is evaporation, and this one will be reversible isentropic. Okay. So if we study this reverse Carnot cycle, we can have the comparison between reversible Carnot cycle and the vapor compression refrigeration cycle. So we are finding two major modifications. Okay, in the vapor compression refrigeration cycle, we are getting two main modifications. First modification is that in this reverse Carnot cycle, we have process 1, 2. Okay, so here it is at the wet. Here the moisture content is high. This is not saturated. Okay, not saturated. So we are finding two modification in the vapor compression refrigeration cycle. First difference is modification is process 1, 2. Okay, so this 1, 2 process is slightly different from the vapor compression refrigeration cycle. Another modification is that process 3, 4. Okay, here the process 3, 4 is reversible isentropic process. Here entropy is constant, but in our refrigeration cycle enthalpy is constant. Okay, but here enthalpy is not constant, here entropy is constant. So there are two modifications. One is process 1, 2 and process 3, 4. In vapor compression refrigeration cycle, we have the isenthalpic, where enthalpy remain constant. But in case of reverse Carnot cycle, we have the reversible isentropic process, where the entropy will remain constant. Clear? And for the first modification, in the vapor compression refrigeration cycle, we have one at this saturated point. So the condition of point 1 is saturated. Here it is wet. So in this case it is wet, but in our refrigeration cycle it is started from this saturated point and it directly goes to the point 2. Here it is superheated. Point 1 at the saturated condition and then point 2 at the superheated condition. So here in this Carnot cycle 2 is saturated, but in case of vapor compression refrigeration cycle it is superheated. In case of Carnot cycle, point 1 is here. In case of vapor compression refrigeration cycle, point 1 is at saturation condition. So if we see, we'll find out vapor compression refrigeration cycle 1, 2. So this is the first modification. Okay, the first difference is process 1, 2. It is saturated, here it is superheated. Okay, next change is for the process 3, 4. Here it is enthalpy is remaining constant, but in case of reverse Carnot cycle, we have entropy is constant. So these modifications are made in case of vapor compression refrigeration cycle, because for any compressor the suction point should be at a saturated point. Okay, so compressor, so for any wet steam, for any wet refrigerant, suction to the compressor is very difficult. That's why in our case this suction point of compressor is saturated. Instead of wet condition, it is saturated condition, so that it can easily come to the compressor. And after the compression, the discharge point is point 2, which is superheated. Point 2, which is superheated. So this is our advantage in this particular cycle. Okay, and here it is isenthalpic, because the isentropic process is difficult to be conducted. There is difficulty to have isentropic reversible process. That's why that reversible isentropic process is replaced by the isenthalpic process here. So these are the two modifications which are made in this particular refrigeration cycle. So I hope that you have understood the vapor compression refrigeration cycle, how different components are there to have the proper cooling effect of refrigerator. And we have also understood what are the main modifications made in this particular cycle, because the reverse Carnot cycle is the ideal cycle, and from that cycle this cycle has come. So certain modifications are made in this case so that the processes can be done practically, and there is practical aspects. Now I will solve one numerical which came in the gate examination in the year of 2008. For a Carnot refrigerator operating between 40 degrees centigrade and 25 degrees centigrade, the COP is 1.67, 19.88, 39.74. So this question is very interesting because you need to find out COP for a Carnot cycle. So the problem 1, gate 2008, gate 2008. One, two, three, four. This is 40 degrees centigrade. This is 25 degrees centigrade. So let me solve the problem on Carnot refrigerator. So to solve it, we have two values of temperatures. To solve this or to find out the COP of this refrigerator, we have two temperatures. One is 40 degree higher temperature, and another temperature is 25 degrees centigrade, TS. Okay, so we have T2 is 40 degrees centigrade. T2 is T2 is 40 plus 273, and T1 is 25 plus 273. So suppose here it is rejected Q2, okay, so heat added is Q1. So let me take the heat added equals to Q1, heat rejected equals to Q2. Okay, so we know for the Carnot cycle, COP equals to refrigerating effect by the compressor work, or refrigerating effect by the work input. Cooling effect equals to Q1. Okay, so here the cooling effect equals to Q1, the net work equals to heat rejected by the heat added, so it will be Q2 minus Q1. Okay, so if we solve it, simplify it, then Q1 divided by Q1, okay, Q2 by Q1 minus Q1 by Q1. Okay, so we'll get COP equals to 1 divided by Q2 by Q1 equals to 1. So finally we have got COP equals to 1 minus Q2 divided by Q1 minus 1. Okay, again After simplification, we will have 1 minus T2 divided by T1 minus 1. Okay, so this ratio of Q2 by Q1 is equivalent to the ratio of T2 by T1. 40 plus 273 divided by 25 plus 273 minus 1. Okay, so if you calculate the value, you will get the final. So after calculation, the value of COP will be so after calculation, the value of COP will be 19.88. So your answer is option 3, which is equal to 19.88, the value of COP for a the given Carnot refrigerator. So now I am giving you one question, okay, of GATE examination, which came in 2014. So try to solve this problem so that you can have better idea, better concept. The efficiency of a reversible engine operating between two temperatures is 40%. The COP of a reversible refrigerator operating between the same temperature is 1.5, 2.5, 0.4, 3.5. Thank you so much. See you in the next class. Support me and subscribe my channel. Thank you.